evening, everyone. Thank you for joining me so late in the afternoon for my session, GraphQL, Spring and Kotlin, a match made in heaven. My name is Ronny and I will present to you today. If you followed the tracks today, there was also another GraphQL presentation by Niklas about GraphQL in German. And he was more about the differences to REST and how to design a GraphQL API and an introduction. My talk will be a little bit more hands-on and about how you can get the things running. We will cover 3 topics mainly. First GraphQL, then Kotlin. I will give a short introduction on both to make sure that we are all basically on the same page with our knowledge. And then in the last part, I will cover how we can combine those and create awesome applications. After each section, so mainly after GraphQL, after we covered GraphQL and after we covered Kotlin, I will take a look into the chat if you have any questions. And of course, I will answer questions at the end of the presentation. Due to this whole screen sharing, I cannot take a look into the chat while presenting. So what will I talk about today? As I mentioned, I will first give an introduction to GraphQL to you. We'll talk about what inputs and objects are, queries, mutations, how you can document your API, and then give you a short motivating example. Next topic will be Kotlin. I will give you a very brief overview over the syntax, mainly by comparing it to Java code, which hopefully all of you are familiar with. And of course, in the end, I will come how we can combine GraphQL and Kotlin using Spring. And I created a small example application, which you then can also find on GitHub and check out and extend or use as base. So first things first, who am I? I'm currently lead developer at ProMaterial. We try to bring the construction material industry to the 21st century and make it digital. Additionally, I am interested in all kinds of distributed systems problems. That was already my favorite topic in university. And looking at what we have with microservices these days, it kind of fits. I also worked at Codecentric before. And you could say I'm a Kotlin admirer. Some time ago, when I started using Kotlin professionally, programming really became more fun and more elegant, in my opinion. So I'm really glad that we have this language. And I also studied at TU Berlin and KAIST. So if any of you have questions about Korean food or studies in Berlin, feel free to ask me. My picture is a little bit older. You could say, if you compare it to my screen sharing, it's pre-corona. So, and you can, of course, find my Twitter handle and my blog link here if you want to reach out to me after the presentation. I used to write a little bit more blog articles, but then my wife and me decided to have children, and no, I hardly can write anything down. So that about me. Now let's get started into the presentation by taking a look at GraphQL. So basically, GraphQL is a query language, and usually if you want to use it, a runtime for APIs. So you define your GraphQL API. In most cases, you can find it being used over HTTP. So if you can remember the ISO-OSI layers, I guess from your studies, GraphQL would be one layer on top of HTTP, and HTTP would be the protocol below. And you could replace it with everything that can transport JSON. So it would also be possible technically to use GraphQL over gRPC or something similar. You could even use a binary protocol in theory. And GraphQL itself defines a static API. So everything has to be typed, and you have to write down all the types and define them. So it's very close to Java in that case. And one nice advantage GraphQL has is that consumers can fetch parts of the data. So you're not required to receive all JSON or object or whatever is waiting for you on the other end. In comparison, if you imagine making an HTTP GET to a REST API, you usually get the whole object or JSON or XML that lies behind the HTTP path. With GraphQL, a consumer can specify what he or she wants to consume. In GraphQL, as I mentioned, it's statically typed. You have inputs and types. So an input defines the data that is an expected argument. So here is a small example. We have the input argument. It has two fields, an ID field and a number field. And this is what our API expects to come in. And in contrast, we have types. That is basically everything that your API returns. So here we have a response type with an ID and a text field. And both can't be mixed. That's something one has to get used to when starting with GraphQL. So if you think about a simple API to create something like a person, you would take the person as an input and think like, okay, I would just return the same person to show it has been created successfully. And normally, to avoid duplication, you would just return the same defined object. But in GraphQL, it's a strict separation between inputs and types. And in addition, you can see the exclamation mark here and here on the ID type. Those mark non-nullable fields. So here's a number, for example, and the text could be null, but the ID is never. And this also makes a great combination with Kotlin. Next, we have scalars, so-called in the API. I would call them the atomic types. If you take a look at the documentation, you find like the leaves of the graph. And scalars are basically all types that are built in, like string, int, ID. ID is some kind of a special type because it can be a string, a number, or UUID. And in addition, you can extend the API by adding custom scalars. And that ways you can handle very specific types pretty easy as part of your API. In the example application later, I will show you how you can create your own simple scalar. And to get started with GraphQL, of course, you need a query. There's a special type that is called also query, and this is basically the entry point of the API. And as the name states, it's for retrieving data, like doing an HTTP GET. The framework, the Java framework we will later use, would even refuse to start if you wouldn't have a query type. So it's basically, it's nearly mandatory. The other part, of course, is a mutation. It's also a special type when you define your GraphQL API. And it's the entry point for manipulating data, obviously, as the name states like an HTTP post or put. And the combination of queries and mutations define all interactions that you have with your API. Just a small hint, there are also subscriptions in GraphQL, but for the brevity of this talk, I will just omit them. So if you're interested, you can look it up. And below here, you see my example schema. So we have the schema, that's always the starting point by definition, and followed by the query type and the mutation type. And in the query type, we define a hello field with a string. And in the mutation type, we define an update method with our argument we defined before, and a response we defined before. And that's basically already a valid GraphQL schema definition. What's also included in GraphQL, what you shouldn't forget, is documentation. You can nicely put documentation directly in your GraphQL files. And if you ever want to look it up, it's not called documentation. In the spec, it's called descriptions. And it's actually Markdown that you write there, and you can use all syntactic features. And you can add descriptions basically everywhere in your GraphQL definition. So to queries, mutations, parameters, inline, inputs, and types. Here I created a description on the update. I use 3 double quotes for showing that's a multi-line comment or multi-line description. And as you can see here, hopefully those are the backticks that you're most likely used for Markdown to have some code formatting. And here inline for the argument, I added with single quotes, a single line comment, just to show that it's also possible to do this like inline. And to give you a feeling of what the advantages of GraphQL sind, there's actually a blog article from GitHub some time ago from 2016. And I hope this one can motivate you to give GraphQL a try, since yeah, I'm obviously doing advertisement for it since I'm presenting here. And if you read through the article, you find 4 main points that GitHub mentions for switching to GraphQL. So requests only ask for the data they need. One can avoid overfetching. So when you make a request to a GraphQL API, you have to list the fields or state the fields that you want to receive. And you omit just things that are not of your interest. And that way you can avoid overfetching. And GitHub also mentions that the strongly typed API makes working with GraphQL really nice. And also, GitHub could save requests by navigating the relations. So when you think about it, you have a repository, commits, a committer. And as the name GraphQL states, you should try to modify a graph with your API. And then you can navigate through this graph. And GitHub made, for GitHub, it was possible to combine what was previously several HTTP requests into one GraphQL request. And they could also navigate this relation, so they could avoid underfetching. And lastly, GitHub mentions that they get better error messages. The example you get is that if only parts of the data could be fetched, in HTTP, you would usually receive no data at all and an unauthorized response. With GraphQL, you can actually receive a part of the data and get an error response that states which parts of the data you couldn't get and why. And yeah, if you want to read it up, the link is below, and you will receive the slides later, I'm pretty sure. That was already the short GraphQL introduction. Does anyone have any questions? Basically, the alternative, so GraphQL tries to replace REST APIs by giving a more modern approach. You can, to pick up what Niklas said earlier today, you can think about it as a query language like SQL. So you describe what you want to get from the server, and with this description, you can get a response. And you can also add, if the API is designed like this, some filters or some narrow down the result. I hope this helps. Later, I will show some example queries, and I hope then you get a better feeling. Okay, then I will move on to Kotlin. So what is Kotlin? Kotlin is basically just a statically typed JVM language. And it, in my opinion, it picked the best concepts from Groovy, the nullability and the Elvis operator, from Scalar, the type inference, the val and var keywords, from C#, the extension functions, and finally from Java, the JVM and the ecosystem, because the interoperability is really nice. I don't know if this is an official list and if any of the Kotlin developers would agree, but that's just my opinion. And in addition, Kotlin also replaced Java as standard Android development language some time ago. So it gained quite some traction. So let us start with an example. So on top, you see the very basic Java method. We have the keywords, public final, the response, the method name, the request object, and then you can fill in the method body. And if you compare this to Kotlin, we have some differences. So we have the fun keyword for function. So you can see why programming with Kotlin is always fun, because you have to write fun many times. And I think this joke has to be made every time a Kotlin introduction is given. Public final is default. That's why it's written down there on top. So in Kotlin, you don't have to add any keywords if you want to have public final method or fields. Kotlin follows Scala in the syntax. You have this inverted first the variable name and then the type syntax. And the response types comes after the parameter list, not after the keywords. It's a little bit unusual in the beginning, but you get used to it. To give you another example, here you can see a very basic data class or DTO class for Java. We have an immutable string field. We have a mutable double field. We have a constructor here taking the two fields. We have a getter for the immutable field and a getter and a setter for the mutable field. Normally, we would also add equals hashcode and string here, but to fit it on one slide, I omitted it. So nothing special here. With the Kotlin, we have a really brief syntax, like the scalar case classes or the record types that are going to come in Java. So we have, again, public final as default without adding any keywords. We have a data class here. This means equals hashcode and toString are generated. We have automatic getter and setter creation for val and var fields. And by default, they are also public, visible, and final. And the primary constructor is written directly after the class definition here. So you just write the class name and then the constructor. To give you one more example, here is a very basic code that makes a HTTP request using the string REST template. So we have here a static final field as a default. We create a REST template using the builder. We define a port here. And then we use the REST template, make a call get for entity where we pass the URL, append the port. And we have to pass the response class that we want or that we expect so that the generics for the response entity can be filled. And the body, if you take a look at the Java doc, can actually be null. So we use a helper method here from objects, require non-null or else. So if the body is null, we return the default response, if not the body. So nothing big here. And yeah, you should definitely add some error handling and circuit breakers or whatever in product code, but just for the example, I think it's sufficient. In Kotlin, this looks again a little bit different. So what do we have here? At first, we have type inference. So the gray written REST template here is actually added by IntelliJ, but we don't have to state any types. We use the Elvis operator down below. So since body might be null, we can use this operator to return the default response if it is null. And if you take a look at the line above, you can see the question mark. This means we have a nullable type here. So my response Kotlin could be null. And the compiler helps us with null checks. And here we have two features at once, basically. We have an extension function. So if you check the REST template, the get for entity method with just one parameter doesn't exist. And this is an extension function. So it's a function written in a different file that acts like it's a function on the original class. And we have the so-called Kotlin reified generic here. So we just pass in the generic here for the method call, or we could also type response entity here. And that way the class is already passed on to the REST template and the response will be correctly typed. And one last feature that I used here is the template string. So with the $, we can use variables directly in the string, and we don't have to use a string builder or string concatenation. And in Kotlin, there is the static keyword doesn't exist, so you can't have static final fields. So instead, you use a companion object, similar like Scala, and there you can have something like static constants. Okay, that was a very brief introduction to Kotlin. Any questions about this? Okay, then let's get to the fun part where we combine GraphQL, Spring, and Kotlin. So what do we have to do? First, how can we combine GraphQL and Spring? So there's a library GraphQL Java Kickstart, and this one provides a very nice auto-configuration for Spring Beans or for adding GraphQL to Spring. And you can map queries and mutations directly to Spring Beans. They are auto-detected. And you can also get some test support and test annotations from this library. And also nice advantage here is that the library integrates with the JCON integration that's already present in Spring. So you can use the, I think, well-known JCON annotations and object mapper and whatever you use to write your requests and responses, or to serialize and deserialize them. Combining GraphQL and Kotlin works also pretty nice. So the inputs and the response types can be just represented by data classes. You can use extension functions for data transformation, but that's just what I do, or I would do. And yeah, by using those two mechanisms, you can keep your domain objects free and separated from data transport logic, and could go in a direction of clean architecture. And what's pretty neat is that GraphQL nullability can be directly mapped to Kotlin nullable types, so you are very safe of getting null pointer exceptions. And lastly, to combine Spring and Kotlin, you don't have to do anything here. Kotlin is very well supported, and the only thing you would have to do is adjust your Gradle file or Maven file. So 3 slides back, I had the GraphQL, Spring, and Kotlin symbol, but one symbol from the start of the presentation was missing, if you paid attention, namely the rocket that gets us to heaven. And so how do we get those 3 started? But basically, you just go to start.spring.io. You choose a Gradle, Kotlin, and web dependency project, which you then download. Then in the Gradle file, you add the dependency GraphQL Java Kickstart with the Spring Boot starter and version 8. Please pay attention to the latest version. While I was preparing this presentation, I had to adjust it 3 times in the slides. So 8 is hopefully still the latest. Then we create a simple GraphQL file with a schema, query type, as I explained, and then our hello type that just responds. And then we create a B, and we annotate it with add_component, or you could also use add_service. I just called the class query here, but the name doesn't have to be exactly the same as query. What's important here is that we extend GraphQL query resolver. It's an interface that's needed for auto detection. And then we implement the hello method. So hello has to match, of course, here with the query type, and the response type has also to match. And in Kotlin, we can just write equals foo if we have a very simple method body, so we don't have to use brackets, braces, sorry. And in addition, we need some configuration. So we have the GraphQL servlet configuration. Of course, we enable it. Then we have to add a mapping where to find our API. Since, as I mentioned, I don't cover subscriptions here, so I disabled WebSockets. And for the tools, you can configure auto detection for your GraphQL files. So in my case, I have a source main resources GraphQL directory and their files with the extension GraphQLs, so GraphQL schema. And I enabled introspection. This means our API shows the types and people can introspect it. And that's basically it. Combining those things, you have a valid and running GraphQL application. But of course, that's not everything. Therefore, I created an example application, a simple to-do list application. And if any one of you attended Niklas' talk earlier today, no, we didn't talk about using to-do items, both, just a funny accident here. So I created a simple to-do application where you can create and update to-do items. They have a title, description, and a severity. And to show how you can design queries, I added several of them. You can search by severity, creation date, and so on. And I also use a tool called Graphi, please mind the I here, QL, which you can use to manually test your API. That's pretty neat. And for the data in the application, I defined 3 classes, a to-do item input, a to-do item, and a to-do item DTO. And you can transform one into the other by using extension functions that you can see below here. So on the to-do item input, I define a new function to new entity, and I create a to-do item, which is a MongoDB document. I assign a UUID. Since extension function acts like it's defined on the original object, I can call this to get severity, title, and notes. And then I create 3 instances for a creation date and a last modified date. And why did I do this as an extension function? Well, on the one hand, I didn't want to put it in the input because by assigning an ID and dates, it's some kind of business logic, in my opinion, or just for the example. And I also didn't want to add it on the to-do item since that one shouldn't mind transforming the input. So they are decoupled. And I guess what you would do these days without Kotlin is just put this logic in a service class. But I think putting it in an extension function works pretty nicely. And the same on the way out, you could say, on the entity to-do item, I call to DTO, and then I fill my DTO. Of course, this is very simple here, but if you think about it, you could need some JSON annotations, and you don't want to have JSON annotations intermixed with your Mongo or Spring Data Mongo annotations. So you could add them here, and the entity wouldn't even know about JSON. And as I promised earlier, we create our own scalar. For the sake of the example, it's a very simple one. It's a date. So an ISO 8601 date format. And what you have to do in your GraphQL definition, you just write scalar date, and you're done. Since a scalar is an atomic type, it cannot contain any more fields. And then in our Java code, we create a bean for the scalar. There is a nice builder here that you can use. You give it a name, a description, and something that's called coercing. This class contains the serialization and deserialization logic. So you have to read some input and write some output. And yeah, by defining the date scalar, we can work with it in our API like it was native to GraphQL. When you type your API, you won't see any difference. And as I mentioned, we have 2 mutations here, something to add an item and something to update an item. So for the add to-do item, we want to receive a to-do item input, of course, never null. And we promise we return a to-do item, also never null. And as you saw earlier in the implementation, we assign an ID, created and modified date. The other mutation is the update to-do item. We require an ID because we want to update something. And I chose to reuse the same input class because it just has 3 fields. You could also define like to-do item update input or to-do item update that defines on your use case and how much difference is there between creating and updating. And in case of an unknown ID, I throw a custom exception, no such to-do item exception. And in the success field, of course, we update the fields and the modified date. Regarding errors and exceptions, when you get a GraphQL response, there can be 2 fields, a data field and an errors field. And of course, errors are shown in the errors field. So if you use GraphQL over HTTP, which you do when using GraphQL Spring Starter, GraphQL Kickstart, then you don't get any HTTP error codes. So every response will be a 200 if your application is running. And if you would throw the exception without any addition, you would get an internal server errors response. And to have custom errors, you set this property in your application YAML, and then the messages of the exceptions are shown. In addition, you can define Spring error handlers to modify this behavior even more. I also mentioned some queries. So in my opinion, there are 2 ways to model queries. You could create a query for each field you want to search on. And you could also create one query with all searchable fields and have them optional. In the first option, you can, of course, with the exclamation mark, state very explicitly that the parameters are required and you don't need any additional validation. The second option, of course, is better if you want to have combined searches by several fields, but still then you have to check in your code that at least one field isn't null. So your API doesn't explicitly state this or your GraphQL definition. For the sake of the example, I chose the first option. So we can search to-do items by ID, by title, by creation, by modification dates, and by severity. And as you can see, the first query returns a to-do item without an exclamation mark. So if the ID is unknown, we will just return null. In the other cases, with the brackets here, we show that we return a list. The list will never return null, and the list itself will never be null. An empty list would still satisfy this definition. So it would be valid to return an empty list as long as we don't put null in it or return null itself. And additionally, I mentioned a nice tool to test our API. It's called GraphQL. By adding this dependency, GraphQL Spring Boot Starter, you basically get it. You can activate it in your application YAML. The endpoint here has to match your other GraphQL endpoint. And the mapping here is where you can reach your GraphQL. So localhost 8080, for example, /GraphQL. And yeah, you get a nice UI for testing. And of course, since this is just Spring configuration, you could override enabled with an environment property if you have sensible environments and don't want to have this UI present. This is basically how it looks like. So here on your left, you have your queries, mutations. You can just type it. It also has auto-completion. Below here, you can use variables in your queries and mutations. So I chose the ID to reuse it. On the right side, you see, or in the middle, you see the response you got. And on the right side, you see the introspection. So you can navigate and browse through your API and click on everything here and then see either the descriptions or the fields and go through everything. And additionally, what we shouldn't forget is testing. There's also a dependency for testing if you need it. It just ends with test. And it gives you a GraphQL test annotation, which is similar to the Spring data test annotation and the the MVC test annotation. So it gives you the minimal setup to run a GraphQL test. And additionally, you get the GraphQL test template, which is pretty nice for testing your API and making calls. And what's even better, I think, is the combination with Kotlin multi-line strings. So there's a short example here below. We just write test template, post multi-part, and then by using the 3 double quotes, we can write this Kotlin multi-line string and even use here the access the variables directly. And this is really nice and readable. You don't have to put this in a separate file. And you have your tests. What do you use to build a GraphQL client? If you want to consume a GraphQL API with Kotlin, there is the nice library created by, it was some travel company. Sorry, I forgot the name. Expedia, maybe. They created a nice GraphQL client. If you have like a JavaScript application, I think the one and only is Apollo GraphQL. So here I started GraphQL in my browser, so localhost 8080/GraphQL. And we can then write here our mutation. As I mentioned, we get some auto-completion. It gives the mutation a name, just M1 or whatever. And then we can call add to-do item. We open it, and we have to pass in the to-do item input, as I mentioned. And we can then give it a severity, high, a title, remember JCON, and some notes, gotta learn GraphQL. And since we get a response for our mutation, we also have to use braces here. And then we can, for example, ask for the ID, the created at, and the last modified at to see if really the field generation works. And when I execute it here, you can see the data field is filled. I have the add to do item, which was the mutation I called here. And as you can see, a UUID has been assigned, the created at and the last modified at, which surprisingly matches today's Zulu time. And then we can create another mutation. And then we call the update to do item. And we pass the ID we got here. Then the update. And we change the severity, for example, to medium. And the title, remember, even more. And we want to get the ID and the severity again and the title again. There's also a prettify button, which comes very handy. And when I run the second mutation, you see has been updated. It still has the same UUID and now a different severity. And if I try to use a mutation, update to do item with an ID that doesn't exist, and something here. Yeah, you get also warnings if you have fields that should not be null and that are null. And if I execute mutation M3 now, oh, I have to pass in the UUID. As you can see, already the first error message. And if I just change it, you can see no to-do item could be found. Of course, there are, since the GraphQL is statically typed, of course, you can use a code generator and generate your Java code or Kotlin code or whatever, since it matches so well. Adding it to the build process might be problematic since it could break when the API changes in a breaking way. But I guess it's a question of your process. Yes, as usual, there's no silver bullet. And if we use the query here to do item by severity, we pass in the severity medium, and we want to get back the ID, prettify, and then we execute our query. And then we can see we also got the one item with the API, with the ID we already know. And if we create another medium item and run our query again, you can see now we have two here. So when you receive when you get a list as response, you only have to state once what you want to have, and then you get it for all items that could be found. So here now we get ID, title, and created at. Thank you for joining me, and enjoy the rest of the day.